Okay, so for question 10, collinear just means the same as parallel. These two vectors are along the same line, so they're collinear. They are also pointing in the same direction, so we know that they're parallel. So for a quick example before I get to number 10, the vector 1, 2, 3 would be collinear to 3, 6, 9, because every component has been multiplied by the same factor, right? My x's from 1 to 3 I've multiplied by 3, my y's from 2 to 6, yep, times 3, and my z's from 3 to 9, yeah, everything's been multiplied by 3. So if I see that there's some kind of number that everything has been scaled by, that'll tell me my two vectors are collinear. So if we look at number 10, the only pair I can really start with is my z values. Right? I'm looking to see what have I multiplied 8 by to get to 12. Because unlike this one, I could figure out, okay, everything was times 3. This, I need to start with the two numbers that I actually have and kind of work backwards. So if I double 8, that gives me 16. That's too big. I think my factor I'm looking for is 1.5. So for two things to be collinear or parallel, we've multiplied all the x, y's, and z's by that same factor. So my q has to be 2 times 1.5. So it tells me q has to be 3. If I go p times 1.5, I should get 4. So maybe I'll write that here. P times 1.5 gives me 4. So p should be whatever 4 divided by 1.5 is. So not the nicest number, but we can figure that out. Yeah, 2.6, it's pretty ugly. 2.67, repeat. Maybe that's a bit nicer as a fraction. Yeah, 8 over 3. That's a little bit better. So that's kind of our game plan for when we're dealing with collinear vectors, is seeing what has everything been multiplied by. Okay, the other part of this is part 2, what values will make these perpendicular. So kind of a really awesome thing that we know about the dot product is that the dot product of any two vectors is 0 as long as they're perpendicular. So we can kind of apply that here. So if I'm looking for what values of A and B will make, what values of P and Q will make these vectors perpendicular, I know then A dot B has to be equal 0. So we have a lot of different ways of multiplying vectors. For dot product, we're essentially multiplying similar components. So if I think A dot B, that would be my x's multiplied together, so 2 times Q. Then I go my y's multiplied together, so P times 4. So I can go 4P. And then the z's, so 8 times 12, giving me 96. So my dot product is when I take each similar pair and then I add them all up. So like I said, two vectors are perpendicular if their dot product is 0. So 0 equals 2q plus 4p plus 96. And with this one equation with two unknowns, we don't actually have a way of solving this, right? There might be one answer that works, there might be lots of answers that work. So let's maybe pick one. Something that's easy is probably 0. So let's say if q equals 0, then I get 0 equals 2q, so 2 times 0, plus 4p plus 96. So that's awesome, that's gone. So 0 equals 4p plus 96. Maybe I bring that 96 over. And then I go negative 96 divided by 4. So one option is that q is 0 and then p has to be negative 24. But we might have other options, right? What if p was 0? What if, p was 12? What if p was negative 6? When we have one equation with two variables, there isn't actually just one solution. There are going to be many, many different solutions. So that's kind of what question B is getting at. Are the values of P and Q unique? Well, no, there are lots of different pairs, and this one that I solved for was just one of them.